Hello everyone. We are glad to present our project on timetable management system and developed as a part of our coursework at GM University under the Department of Artificial Intelligence and Machine Learning. I am Sharath, and along with my team members Shriyari, Altaf and Jeevan, we have worked under the guidance of our respected assistant professor Nisha ma'am. Let's dive into the details of our system. Next contents. Here the contents this presentation will walk you through our objective in a structured way. We will begin with an abstract and introduction and discussing the problem statement what we have to aim to solve and move through the objectives and literature review methodology and then system specification we can discuss and finally wrap up with the references. Next abstract. Here, our timetable management system will is well-based solution designed to automation and the creation of and management of academic schedules for students and faculty. It eliminates the hassle of manual scheduling by assigning classes to the time slots while avoiding conflicts. The system features access control, ensuring that only authorized users like admins, faculty, or students and can view the or make the changes in the timetable management. The benefits which is include reduce the human error and faster updates we can see and improve the academic efficiency. Here are the abstract overview of key functions and benefits and then in introduction slide. Here we can see why system is needed and what it does help and what who it helps. And here manual timetable creation is not only tedious but also error prone. Our system automates the entire processes and ensuring the conflict free scheduling for institutions. This solution is designed to serve faculty, students and administrators by simplifying the academic schedule management. These are the abstract and the introduction. Next my friend Altaf will continue from the forum statement.
Thank you, Sharath. Now I'm going to discuss about problem statement related to our project. Manual scheduling is a time consuming. Creating timetables by hand takes a lot of times and efforts, especially in large institute. Manual scheduling is a time consuming, and creating timetables manually is a tireless and inefficient process, especially in a large institute where coordinating multiple departments, faculties, and rooms becomes complex and maybe challenging. High risks of errors and conflicts. Overlapping classes or faculties assignments can quickly occur without an automated check. High risk of errors and conflict. Manually scheduling often leads to errors such as overlaps, double booked rooms, or assigning faculty members to multiple classes at the same time, resulting in confusions and disturbance for the students. Lack of real-time updates. Changes like class cancellation or faculty availability updates requires manual correction, which can delay communication and lead to outdated information being circulated and can miss the times. No centralized system. In absence of a unified platform, different departments may handle scheduling independently, causing inconstant and poor coordination across the institute, and they can create misinformations. Next, objectives of the project. In objective of the projects, we are having a four parts: automated timetable creation, prevent scheduling conflicts, provide easy update and modification, improving efficiency and accuracy. Automated timetable creation. It will reduce the manual efforts by generating schedules digitally, prevent scheduling conflicts, ensure no overlapping of classes, faculties, or rooms. In provide easy updates and modification, it will allow quick changes to schedule through an innovative interface. Improve efficiency and accuracy. It will minimize the human errors and speed up the scheduling process. In academic institute, manual timetable scheduling remains a complex and labor-intensive task. The process is highly prone to human errors such as overlapping classes, double booked faculty members, and conflicting rooms assignments. Moreover, the absence of centralized system and real-time update capabilities often result in poor communication, inconsistencies, and delay in scheduling dissemination. To avoid such problems, we have created this project. Thank you. Now, my friend Jivan will continue.
Thank you, Altaf. We can come to the literature web. Earlier approach relied heavy on mutual entry Excel sheet which lacked of error checks. While ERP systems are available, they often too costly to acquire the training. Academic research suggests the use of AI and genetics algorithm for scheduling, but these may overkill the smaller institution. May existing of tools and lacks of customization, user-friendly interface which we have considered in the our designings. Come to the methodology part. A methodology part here consists the phase of consists of six type: requirement analysis and system design, development and testing, and development and maintenance. Our system follows a web-based architecture with a clean intuitive front end. The core methodology includes the mapping classes and faculties and rooms, the specific time slots, and discussion algorithm to ensure smooth operation. We also consider the axis of roles of different user, admin, faculties, and students. We have front end interface. Altaf front end interface. This is the time management system. Hello. Time management system and front end interface. Here is the snapshot of our user interface. It allows the user interact with the visual in timetable, make updates easily, print or save schedules. We have ensured the design's responsibility and simple to use to keep the end user in mind. By showing this how it will work in academic timetable management. Altaf. Day. Shreyari add a day. Time slot. Course and room. This is how the academic timetable management system of our front end system. Thank you. Let's continue the Shreyari.
uh, Hardware and software specification. Process. The process, there are many types of components: process, RAM, hard disk, monitor, and internet connection, keyboard, mouse. Firstly, I seen this process. Process Intel Core i3 or higher. In this process, ensures your system can handle web-based development tools and browser-based application without lagging. React application specifically those with interactive UI can be resource intensive, hence the minimum i3 recommendation. Next, RAM. RAM minimum 4G RAM. Ensures smooth multitasking such as running Visual Studio Code, a browser, and npm scripts simultaneously. Less than 4G many lead to slow development and debugging. Next is hardware disk, at least 250 GB. Provides enough space to install development tools like Node.js, VS Code, and save project files. Also allow saving dataset libraries and compiled builds. Next is monitor, 15.6 HD or higher. In UI design and testing require good screen resolution. Larger and clear screens help developers visualize responsive layout better. And then next one is internet connection, stable broadband Wi-Fi, essentially for downloading libraries, fetching updates, accessing documentation, and collaboration development. Example, GitHub, and also crucially when using cloud-based APIs tools. Next one is keyboard and mouse. keyboard and mouse, standard input device, necessary for coding, navigation, and testing the interface functionality. Next is software specification. Front end JS, React JS with HTML, CSS, JavaScript. In React, JS is a modern library for building interactive user interface. It, it is a fast development server and build tool that optimize the performance of React app. HTML, CSS, and JavaScript are the fundamental web techniques used alongside React to structure style and bring interactivity to the application. Next is development. In development, Visual Studio Code and Node JavaScript npm. In Visual Studio Code, a powerful code editor with extension for JavaScript React. In Node.js also allows running a JavaScript outside the browser and essential for managing project dependency. And npm node project manager, it is a node project manager. It used to install libraries like react to print or react out router dom. And next one is operating system, compatible compatible with windows, mac os, and linux runs or browsers. This system cross-platform and runs in any modern browser, so it works on Windows, Mac OS, or Linux without needing a separate version. Next is additional libraries are used. React to print for printing, downloading timetable. Second one is React and React DOM for building the UI, and optional React router DOM in navigation between views in the needed. And first one, React to print. React to print enable user to print or download timetable views directly from the browser. And the next one is React to React DOM. Core libraries for creating a rendering components. The React router DOM allows navigation between different views pages, useful for large system with multiple screens, example timetable list, settings, etc. And third one is optimal React router DOM. If navigation allows between different views pages, useful or useful for large system with multiple screen, example timetable, and etc. These are the references. Pasha MA and Begum A 2016 automated timetable generator using genetic algorithm. In Pasha and Begum discussed the automated timetable generation approach using the genetic algorithm useful for understanding the logic behind timetable automations. And Abdullah M and Khairuddin NH in 2014 a review on timetable scheduling problem and solution, Journal of Computer Science and Engineering. This Abdullah and Khairuddin 2017 a review scheduling problem which may influence the design of the algorithm or UI structure. And Valid and Khan M 2021 is focusing on a web-based timetable system aligns closely with the project scope. And thank you.